So today is December 21st, 2017. My name is Dr. David Warshaw. I'm Chair of Molecular Physiology and Biophysics here at the University of Vermont. And we're here today to interview Dr. Edith Hendley for the American Physiological Society's Living History Project. Dr. Hendley has been a member of the American Physiological Society since 1955 and also has been affiliated with the University of Vermont here since 1973. Dr. Hendley is an active member of the department. She teaches physiology to medical students at present, and her expertise is in neurochemical physiology, really a neurophysiologist. And she used to study neurochemical signaling pathways in the brain and how it relates to stress, especially social stress, and the effects that such stress has on the cardiovascular system and other organ systems in the body. Edie, I'd like to welcome you today, and hopefully we'll be able to learn a bit about your living history.
Thank you, David. And I want to thank the Physiological Society for inviting me to do this. I think it's important to remember what it was like in the beginning for me, to bring it up to date to what the society is like now. And I'm happy to share my memories of what it's been like to be a physiologist.
Let me also interject here that I was a student of Edie's back in the mid-'70s, and for me, it's a true honor and a pleasure to be here with you, Edie.
Yeah.
So let's start off by asking you a few questions. Can you tell me about your family upbringing and how that brought you into science?
Wow, my family upbringing, my parents emigrated from Italy in the 1920s and raised a family of 8 children, and we lived in the Depression, absolutely nothing going for us, except that we lived in New York, where New York City had the most incredible educational system, and they took really good care of families like mine. My father worked for one of those WPA jobs that the Roosevelt era started we were able to survive during the Depression. So the important thing was the school system. They were excellent. The school that I was brought up in was essentially closed down in the 80s, totally bombed out, totally ruined, because it was in the South Bronx, which is now iconic for decay. In my day, we were upwardly mobile. 5 students from my elementary school went through with me to junior high school, and 5 of us were chosen to attend Hunter High School, which is a select program of only 400 kids from the whole city of New York. And 5 of us came from my elementary school. I mean, that's the kind of education that we had in New York. And going to Hunter High and then Hunter College, I was able to go to college tuition free. I paid $8 a semester, and they gave me books. I mean, that's the value of the educational system that used to be, and is why, of all the contributions I'm asked to give, I always give to schools like Hunter that bring up students from unprivileged backgrounds that they can single out because of their merit and help them along.
So you went from Hunter High School to Hunter College.
Yeah.
And there, I gather, your passion for physiology was born?
Yes. Hunter College luckily had, first of all, we were all girls, all women at that point. I did not encounter male students till I went to Ohio State for a master's degree. And you know, this was very important. There was a study that showed women Ph.D.s this was a study done back in the 60s. Among women PhDs, a vast proportion had come from girls' schools, all girls' schools. And I still think that this is something that I don't want to see go away. Hunter has become co-ed, so have all the city colleges in New York. And I think something got lost in that.
So was there a particular course or a particular professor that really piqued your interest?
Yeah, that's the other thing Hunter had. They had an affiliation with Columbia and NYU in the sense that their professors came. They had PhDs from those institutions. And I remember having the neurology in my physiology course at Hunter, which incidentally was unusual. Physiology courses were not given in colleges, but Hunter had one. And one of my professors had gotten her PhD at Columbia, and she turned me on to neuroscience. She brought in a film, and I watched it, and I diagnosed something. I was so proud of myself for having learned from this film. I mean, it just was magical. Another thing that happened to me in junior high school was to watch this laboratory exercise where the teacher stood up in front of a bench and she poured, I guess, potassium permanganate into hydrochlor, I don't know, I forget what the chemicals were, but they created bubbling oxygen. You know, this kind of thing really turned me on to science. And then physiology, having taken the course at Hunter, is what determined my career from then on. I was a sophomore, and I became a physiology major, and then I went into physiology master's degree, physiology PhD. And I still consider myself a physiologist, even though I've become more neurochemist in my later years.
So speaking about physiology, do you remember your first American Physiological Society meeting?
Yes. I was a graduate student starting out at Ohio State University. And in those days, the American Physiological Society used to meet with FASIB at Atlantic City in the spring. And then in the fall, they would go to campuses and live in the dorms, whatever. And here I was, first year, and I got to push slides.
What's a slide?
You remember those big lantern slides?
Yep.
And I got to push slides. I felt quite honored by that. That was my first meeting. And then during, of course, you know, then they got bigger and bigger, and attending FASIB meetings. And in those days, women were absolutely the minority. And I remember feeling how wonderful it was when you go to these big meetings and you stop to use the ladies' room and they were half empty. And the men's rooms were always full. And it's at one of those meetings, now this was in the 70s when the women's movement was starting, and there used to be these receptions for the ladies, meeting the wives of the men who came. And we, as a few female professionals, would attend them. And one was given by I forgot the name of the people who supply rats. I'm blanking.
Charles River?
Charles River.
Right.
Charles River gave an annual reception for the ladies. And we sat there and looked at each other, and among us were some really powerful women from NIH who were experiencing the worst kind of discrimination against women advancing. And they said, why don't we start our own organization? And it was at FASIB that we decided to start the Association for Women in Science, and then it grew, empowered by the 70s, when there was a real push for civil rights and for women's rights. So it was a very heady time, but it started with us at one of those annual meetings.
So I know that's one of your passions.
Yeah.
Is and potentially one of your major marks in science is making certain that you can influence the life of women in science.
Yeah.
And so you were one of the founders.
Yeah,
of the
I was
society.
one of the founding mothers of AWIS, the Association for Women in Science, and it was at a time when we had a support from Congress. That was a very important thing. We had a very powerful president of AWIS, Estelle Ramey, who was one of my mentors, and she was able to work with Senator Kennedy, Ted Kennedy, and put through the Women in Science Act that really facilitated the role of women in science. That plus the Education Act that was passed in the Johnson era, where Title IX and Title VII were an important addition to the Civil Rights Act, saying that you must give women equal opportunities in hiring and getting on boards, and all kinds of entries into the power structure. And it gave students the power to be accepted at medical schools and law schools and so on. So it was a very important, the Title IX and Title VII were really the important things. And then what happened at the time I came to UVM was in '73. It was at the height of women's coming out with federal support, where it was mandated if you don't abide by Title VII and Title IX, we're taking away NIH funding. Now imagine what that does to a university. And we turned on a dime. Dean Luginbuehl, to his internal credit, immediately increased, he put women in the dean's office, Lee Phillips, in admissions. Within 2 or 3 years, we had 50% women applying for our medical class. There were only 8 when I first came. 8 in a class of 93, I think it was. Wow. There were women. Within a few years, we were up above 50%. And what I particularly liked was Dean Luginbuehl did was he converted when our students went into the hospital, there they really had problems. The medical school was on target, but not the hospitals. And so he worked with the hospitals to give the women locker rooms in surgery so that they wouldn't have to go to the nurses' quarters for their prepping, where the male students went into the coffee room with all the powerful surgeons. And they never got to get that bonding. So a simple step like that. And today, I'm just amazed at how many women are in radiology, surgery, all the high earning professions that they were barred from. Our women mostly went into pediatrics and OB, GYN, and primary care. They didn't dare try to go to radiology and surgery, and now they do. I mean, I saw this, if I'm not getting too winded on this, but there were only 4 tenured women when I first came. I was one of 4 in the College of Medicine among all of our faculty. And one of our medical students, her mother was a dean at University of Maine in Orono. And this student told her mother how wonderful the professors were, her female professors were. And they were Paula Fives-Taylor and Pat Krupp in anatomy and myself. So what this dean did was invite us to the University of Maine several years in a row, because they had no women scientists there. And we went there just to be a presence for a weekend, giving them some sort of inspirational messages. And I mean, that was the climate. And just think of how that has changed.
So I can say you truly were a role model.
Well, that's what they tell me. I'm a role model. And I'm delighted.
So let me go back to your personal history again in science. So, you know, to be in the area that you were an expert in, how did that come about, and were there particular people who were influential?
Yeah, most importantly, incidentally, I would love to go into what it was like to try to find my first job. That was a story I would like to tell. But one of the things that I did was having to follow my husband, because it was difficult for me to get a job after I obtained my Ph.D. So wherever my husband went, who was a biochemist, Ph.D., is where I would try to get a job. And so he was hired after a fellowship in England that he had. We came back to the U.S. and he had a job in Baltimore at an NIH-affiliated Johns Hopkins appointment. And I applied for a job that in the Department of Pharmacology, of all places, because they were dealing with catecholamine systems, which I had been very much interested in with stress and with adrenal work that I had done in my master's degree, and with cardiovascular work I had done for my PhD. So I appeared to ask for a job with Saul Snyder.
What type of level job were you applying for?
Oh, this is postdoc.
Just a postdoctoral position.
I mean, you know, I couldn't hope for anything more at that point. But postdoc money was available. So I got into Saul Snyder's lab. Now, this is a man who almost got a Nobel Prize. There was some political stuff that happened that prevented him from getting it. But this man, he was only 29 when I joined him. He's an absolute genius. And an expert in catecholamines and other biogenic amines. And I joined his lab. I had small children, 3 kids, wow, growing up, working 3 days a week. And I published, in the 5 years I was with Saul Snyder, I published 8 publications and a couple of book chapters. I mean, this was such a productive time in my life.
Can I hire you now?
I mean, and this is, you know, you walk in and you're surrounded by the climate at Johns Hopkins was first rate. We were right up there, and you made every hour count when you were a mother of 3 children coming there from 9 in the morning, go home at 2 because the babysitter was there, you know, and you made every hour count. You didn't go out to lunch. You just got your work done. Every day was an experiment that I could put in my book and write up in 6 months. So he was a very important mentor in how to do top-notch science. And that's how I became interested in neurochemistry. It was a time when the field was burgeoning. Drugs were becoming available that affected the brain, and where did they affect it? On neurotransmitters, which were included, very importantly, the catecholamines, like adrenaline and noradrenaline. So this is how I stayed with it, and then just happened to do an interesting experiment in the spontaneously hypertensive rat. We decided to look at its behavior, because I knew that behavior affected some neurochemical pathways. And we found that they were incredibly active. It was an astounding, oh my God, nobody looks at a hypertensive rat as a hyperactive rat. Mm-hmm. And I thought, this is contaminating the model of hypertension, because the same pathways that determine high blood pressure can also determine behavior. That we knew. And so I set out to separate those two traits, and that's, I guess, my contribution. I separated the hypertensive trait from the hyperactive rate by making two different strains. And then the rest of my research career was using those two strains plus the original parent strains, the spontaneously hypertensive rat and its control normotensive rat, the WKY. Those four strains would allow us to say, this change happened in only the two hyperactive ones and not in the two normal active ones. And that kind of correlation was what led my research.
What's interesting is those strains that you developed became a resource for the entire community of neuroscientists.
Yes, I would, and I made them available free. Whoever wanted them, I thought, I don't have an empire of a lab. I never aspired to that. I'm not good at that. I didn't want that. And I thought, let me give my rats to others. Let them do it. That has been so fruitful. And so people all over the world worked with my rats.
So in 1973, you came to the University of Vermont here, and the chair at the time was Dr. Norman Alpert, who we both know quite well. Tell me what it was like coming here, and what was the department like then, and maybe how it compares to the department now.
Now, and that's where I want you to help say. When I first came, Norman Alpert, I cannot praise enough. This is a man who hired me, a mother with 3 children, who was a research associate in her position at Hopkins. He offered me a tenure-track job as associate professor because he thought I could bring neurochemistry, which was needed for the neuro project that our department was part of his mission. Norman had the philosophy that we should have our faculty that interact with each other because they can give each other all kinds of ideas and enhance what they're doing. And he thought he himself was a muscle physiologist, which David is. So muscle was an important subject. Another was neurophysiology. He brought in Rod Parsons and Ray Gibbons, who impaled heart muscle cells. He brought in George Webb, who worked with the squid axon type of experiments. So neurophysiology, and Dave Whitehorn, a very important member. So he had neurophysiology, muscle, and what was the third? I'm trying to remember.
So he
For
had,
some reason I'm blanking out.
I mean,
cardiovascular.
Right.
Cardiovascular. He had Bert Hamrill and your mentor,
Bill Halpern.
Bill Halpern.
Right.
And so he felt that Dave Whitehorn particularly said neurochemistry is a very important part of neurophysiology. It was just blossoming in that era. He said, Edith Hendley can come and bring us neurochemistry. And they were planning a program project at that point. So I became a part of, if I would come, I would be a part of that program. Incidentally, the program died because the man who proposed it died. And so we never did get that program project. But that's what Norman did. He brought in people who would interact with each other, which I thought was an excellent philosophy, which I think you now do, of people who interact, because they enhance what they're doing.
So back then, everybody in the department had, I'm assuming, a degree in physiology.
Had a what? A
degree in physiology.
Yes.
And so how do you as a bystander now, as a participant in the Department of Physiology now, that's not the case.
No.
And how do you feel about that?
Yeah, well, I feel like I'm not good enough to understand what they're doing. I honestly don't. It's structural biology that I'm trying to get on top of. I really don't understand intricate biophysics. I'm not very good at anything requiring a microscope, because when I look through microscopes or binoculars, the visions dance for me. I never was comfortable with a microscope. So in that sense, I don't feel like I fit in like I used to. But that's okay. I'm retired.
So let's go on a tangent for a second, okay? And since this is a part of the American Physiological Society's program here, what do you think is happening to physiology?
Yes, I worry about what is happening to physiology. You know, I watched it go from systems to cells to molecules. We're now down to molecules, as you, an expert, know. And I remember sitting on a thesis committee not long ago, even after I was retired, I sat on a committee, where the student was taking a cell out, well, she did have a cell, and got down to some molecule. And she happened to mention that it came from an animal that had been thyroidectomized. And I said to the student, well, what happened when you thyroidectomized? She didn't know. I was appalled at that. I think you have to know, even when you're down to a molecule, what the whole body is doing. And so this is why I continue to teach. I want students to know the whole cardiovascular system, the whole endocrine system, GI. They're all important, and they're lost. My own graduate students did not become members of the American Physiological Society. They joined the Society for Neuroscience. Your graduate students go to Biophysics. We don't, something is lost by losing physiology.
So I agree with you 100%. And I agree with your assessment that we started at the systems level and then came down to the cellular level and then down to the molecular level. And we're at a time now where we should be able to build the system back up again, knowing what we know at the molecular level. And I think you and I, as card-carrying physiologists, should make that our cause célèbre going forward.
Exactly. This is why at age 90 I continue to teach, because I think I have something to give these students. And it is so gratifying when they give me back evaluations that make me feel valued for giving it to them.
I can personally tell you, you are valued. You're valued as a professor and a teacher of medical students. You're valued as a mentor in my department. And I think you provide a living history. And so one can ask you, what advice would you give a student now who maybe is starting off in this career?
Yeah, right. Well, you know, Norm Alpert used to say, when we went through funding lapses, you remember this, David, in the 70s, the budget from NIH went down, then the 80s, then the 90s, and now. And a lot of students I've watched just leave the field. I remember one of our graduate students saying, I have to compete with 200 others for a job, and I may not be able to get funded by NIH. I'm getting out of this. And Norman's attitude was, be the best you can be. Yes. And then you will get the grant when nobody else gets it. Just be the best. And the best you can be is doing what you love. If you're not turned on by it, go be, you know, a producer of a play if that turns you on better. But you gotta love what you're doing. And you've gotta give it everything you can.
So I see you as a success story, but I'm certain there must have been barriers that you had to overcome as a woman.
Oh, yeah.
As a scientist. But I can only imagine that those barriers, even though you tried your best to lower them as much as you could, that maybe some of those same barriers are still there. And what advice would you give people in terms of circumventing those?
Yeah, it's interesting. When I got my Ph.D. In 1954, I went out for my first job. And in those days, the American Physiological Society had a session for graduate students to be recruited. And professors would come and make appointments, and you go in for your interview for a job. Well, this was so awful for me. I felt like I was on the meat market. It was just awful. I don't think they do it anymore. I hope they don't do it anymore. But what happened with me was there was a graduate student who was in cardiovascular Ph.D. as I was. I had better grades than he did. We both were interviewing for a job in Boston in cardiovascular at assistant professor level. And I needed to restrict job hunting to a big city so my husband and I could find jobs in two different institutions, because they wouldn't hire two people in the same family in one institution in those days. Now it's different, and I can explain why. But at that time, we were both interviewed. We both put in our name for an interview. I never was even asked. He got the job in Boston. That kind of thing happened to me. But a lot of good things happened for me. And one of the things I want to pass on to young students, find a supportive person to work with. That was the most important thing I could have done. Norman Alpert was my advocate, my champion. He hired me when it was absolutely, crazy to hire a woman with 3 small kids. He hired Larry McCrory when nobody had a black faculty member. I mean, this was Norman. He saw the good in people no matter what flavor they came in. And this was a really, this was an eye-opener for me. And one of the reasons that I haven't had more discrimination against me is because I have always been in an environment where people valued me, which I now so greatly appreciate that you value having me. And if I didn't feel valued, I would be out.
So are there any things that you would like to sort of pass on now as sort of a final statement?
Yeah, the one thing I said was to love what you do, find a supportive environment. And there's a third thing, interesting. For a graduate student, don't choose the big mecca universities. You get swallowed up in them. You're much better off in a small, excellent school. I remember Amy McDermott. Do you remember her as a graduate student? She went to this little college called Wells in New York State, where it was a small college, where you were mentored closely and supported closely. And there's where you should get your training. And then you go on to the biggies, the Harvards and the Princetons and UCSF, where you just get swallowed away. My own graduate student who went off to UCSF, he hated it. Yeah, you really need to be nurtured in the early part of your career. And you get that best in a small, supportive college.
So Edie, I want to tell you this has been a personal pleasure for me. I also want to say that I know the students that you have, I'm going to say for them, they thank you for all of your mentoring and all of your energy and passion that you provided for them. I'm certain that that's a part of their fabric going forward, and that their students and their students should be thankful for who you are.
Thank you, Dave.
And I want to thank you from the part of the American Physiological Society as well. For me, this has been an honor. Thank you, Edie.
Thank you, David.